dear students, welcome to Easy BTech, your guide for BTech and beyond. And we are discussing signals and systems subject. And today's topic, Hilbert transform, very important topic. And before going to our topic, Hilbert transform, all of you subscribe, share the channel. This channel is very helpful to you. So let's start our session, Hilbert transform. What is Hilbert transform and what is the use of it? We discuss in detail. Let's see now Hilbert transform definition. What is Hilbert transform? Hilbert transform. Very important topic. So I am taking first a continuous time signal x of t. Consider a signal x of t. So its Hilbert transform is defined as x cap of t is equal to x of t convolution 1 by pi t. So convolution of a signal x of t with 1 by pi t, that process is called Hilbert transform and it is denoted as x cap of t. Cap symbol we use. So here the star mark is convolution. What it is? Convolution. Right? Now I am going to write convolution. What is convolution? So we know convolution integral or convolution. If we have two signals x1 of t, x2 of t, the convolution of x1 of t, x2 of t. So convolution is integration minus infinite plus infinite x1 of tau, x2 of t minus tau d tau. And the convolution is commutative. That means x1 of t convolution x2 of t is same as x2 of t convolution x1 of t. So it is commutative. That is why we can write another integral like x2 of tau into x1 of t minus tau d tau. So both are same. Both will give same results. Right? Now I am going to write this convolution integral for the Hilbert transform, whatever we have. Here x of t is x1 and 1 by pi t is x2. So as per that, x cap of t is equal to, so integral minus infinite plus infinite, okay, x of tau 1 by pi t minus tau d tau, right? And we can also write in this way also. So integral minus infinite plus infinite 1 by pi tau into x of t minus tau d tau, right? And here I am going to mention one point. What is that point is? Hilbert transform does not changes the domain of the signal. So before Hilbert transform, the signal is in time domain. After Hilbert transform also, the signal is in time domain. So domain of the signal not changes. That is a point. Domain of the signal not changes. So before Hilbert transform, after Hilbert transform, the signal is in the same domain, time domain. So domain of the signal not changed or changes. Okay? After Hilbert transform also, the signal is in same domain. So x of t is the signal. Its Hilbert transform is x cap of t. So both are in time domain only. Both are in time domain. That is the point here. Right? And next thing, I am going to see Fourier transform of x cap of t. So So we know that x cap of t is equal to x of t convolution 1 by pi t. So apply Fourier transform on both sides. Apply Fourier transform on both sides. That is, Fourier transform of x cap of t will be what? Fourier transform of x of t convolution 1 by pi t. So right side we have convolution x of t 1 by pi t. So in Fourier transform we have a property, convolution property, time convolution property. Convolution in time domain will become multiplication in frequency domain. Convolution in time domain is equal to multiplication in frequency domain. Right? So this we are going to use now. Multiplication in frequency domain. Frequency domain. So now x cap of t will become x cap of omega Fourier transform after Fourier transform, and here convolution in time domain will become multiplication in frequency domain. So Fourier transform of x of t into Fourier transform of 1 by pi t. So multiplication I am taking. So x cap of t that is Fourier transform x cap of omega. Here x of t is x of omega Fourier transform x of omega, and 1 by pi t Fourier transform. What is the 1 by pi t Fourier transform? Minus j signum of omega. This is the 1 by pi t Fourier transform. So how it is, we will see this 1 by pi t Fourier transform. So we know duality property, that duality property is used now to see 1 by pi t Fourier transform. So we know that signum function Fourier transform, Sgn of t Fourier transform. So Fourier transform of Sgn of t is equal to 2 by j omega. Now duality property I am going to use. So 2 by jt Fourier transform will become, what it will become? 2 pi signum of minus omega. So this is a duality property. So both sides we can cancel 2. Then 1 by pi t we want. So bring that pi right side to left side. Then the answer is, here signum of minus omega. Signum function is a odd function. It is a odd signal or odd function. So minus here j signum omega. Right? So 1 by pi t Fourier transform is minus j signum of omega. Now if you see signum function, if you plot it signum of omega, just we are plotting signum omega. So it is plus 1 when omega is greater than 0, and it is minus 1 when omega is less than 0. Right? So x axis is omega, plus 1, minus 1. This is the signum omega. So what it is saying, signum omega is equal to 1 when frequency is greater than 0 or positive, right? And it is equal to minus 1 when frequency is less than 0 or negative. So according to this, we are going to write x cap of omega. Just signum function we are taking into consideration. So x cap of omega will become x of omega minus j into 1. So when it is 1, when omega is greater than 0 or positive. And same x cap of omega will become x of omega minus j into minus 1. So when omega is less than 0. So minus minus plus, so it will become j x of omega. And previously minus j x of omega. So finally x cap of omega is equal to x cap of omega is equal to minus jx of omega, right? When omega is greater than 0, positive, frequency is positive, and plus j x of omega when frequency is negative, right? So now if you discuss magnitude spectrum of x cap of omega, x cap of omega magnitude is how much? So here we have plus j minus j. So magnitude how to write? Under root of real part square imaginary part square. So here minus x of omega whole square, it will become plus x of omega whole square, square root get cancelled, and here x of omega whole square. So even frequency is greater than 0 or less than 0, the magnitude of x cap of omega is same as magnitude of x of omega. That is the point here. So I'll just repeat once again. X cap of omega is equal to minus j x of omega when frequency is positive, and it is j x of omega when frequency is negative. So what about magnitude? Magnitude of x cap of omega. This is magnitude. So what is the magnitude? So magnitude of x cap of omega is magnitude of x of omega. Magnitude of x cap of omega is magnitude of x of omega. That means the magnitude spectrum is same. Magnitude spectrum is same. X of omega magnitude spectrum, x cap of omega magnitude spectrum is same. This is the point. Next, what about phase? What about phase? So if you write phase, angle x cap of omega. So phase is equal to tan inverse imaginary part by real part. So here real part is 0. So if you take omega is greater than 0, we get tan inverse minus tan inverse x of omega by 0, right or not? So real part is 0, imaginary part is x of omega, and minus x of omega I am writing minus tan inverse. This is for omega greater than 0, and tan inverse infinity it is, right? So tan inverse infinity is pi by 2, so minus pi by 2 when frequency is positive. Similarly, when frequency is negative, what is the phase? What is the phase? You get plus pi by 2 when frequency is negative. Now if you plot it, phase spectrum, the phase of x cap of omega, when frequency is positive, plus pi by 2, when frequency is when frequency is positive, minus pi by 2, when frequency is positive, minus pi by 2, so phase is minus pi by 2. When frequency is positive, when frequency is negative, plus pi by 2. So this is the angle of x cap of omega. This is the frequency, plus pi by 2. So that means, what it means, x cap of omega phase is plus pi by 2 minus pi by 2 as per the frequency. So when frequency is positive, minus pi by 2, when frequency is negative, plus pi by 2. So here point is, the Hilbert transform provides 90 degrees plus or minus 90 degrees phase shift, plus or minus 90 degrees phase shift. Okay, when plus 90, when minus 90, that depends upon signal frequency. If signal frequency positive, minus 90. If signal frequency is negative, plus 90. Okay. And one more important point about Hilbert transform. So x of t and its Hilbert transform, x cap of t. Its Hilbert transform x cap of t. Hilbert transform x cap of t, or mutually orthogonal. Mutually orthogonal. They are orthogonal, mutually orthogonal. That is, what is the meaning of mutually orthogonal? Integral x of t into x cap of t. So this integral product will become 0 over limits t1 to t2. Okay, over certain limits, certain time instants or time interval t1 to t2. So these are all about, this is all about Hilbert transform. Let's do some simple examples like problem. Hilbert transform of sine omega naught t. So this is the signal, Hilbert transform of sine omega naught t. So he given sine omega naught t is the signal. What if its Hilbert transform? What is its Hilbert transform? So simple, very simple. The solution is x cap of t is equal to, so here frequency is positive, omega naught, positive. So frequency is omega naught, which is the positive. So when the frequency is positive, it provides how much phase shift? Minus 90. Therefore, x cap of t is equal to sine omega t minus pi by 2 or minus 90. So just I am giving phase shift minus 90. That is a property of Hilbert transform that we are following now. Right? So we can write, we can take minus common, then sine pi by 2 minus omega naught t. Sine 90 minus theta. So cos theta. So cos omega naught t. So finally, sine omega naught t Hilbert transform is equal to minus cos omega naught t. Right? So this is a very simple. Similarly, we can do cos Hilbert transform. What is the Hilbert transform of cos omega naught t? Very simple. So here also frequency positive, right? Frequency is positive. Therefore, Hilbert transform of x of t is x cap of t is equal to cos omega naught t minus pi by 2. Minus pi by 2 phase shift. So I am taking phase shift minus pi by 2. Then this we can write as cos pi by 2 minus omega naught t. Right or not? Then cos 90 minus theta, sin theta. So sin omega naught t. This is the answer. For example, you want Hilbert transform of the signal x of t equal to 3 sin omega naught t plus 2 cos omega naught t. So here sin and cos both are involved. Already we have done separately sin Hilbert transform, cos Hilbert transform. That we can do now. So x cap of t, Hilbert transform of this is equal to, so amplitude is same 3. Sin will become Hilbert transform. Sin Hilbert transform is minus cos. Therefore, take here minus cos omega naught t plus cos Hilbert transform. Amplitude is same. Cos omega naught t Hilbert transform is sin omega naught t. So this is the answer. So x cap of t is equal to 2 sin omega naught t minus 3 cos omega naught. So the domain of the signal is same. After Hilbert transform, the signal is in time domain only. So before Hilbert transform, the signal is in time domain, right? So domain of the signal not changes. This is Hilbert transform, right? So to provide plus or minus 90 degrees phase shift, we can use Hilbert transform. Okay. So students, very easy and important topic. So please watch videos regularly. Thank you all.